Let me tell you something that might make you angry. Last month, a customer walked into my shop ready to spend $8,000 on a transmission rebuild. Her Nissan was jerking, slipping between gears, and throwing codes like confetti. 3 other mechanics told her the same story. Transmission's gone. Time to rebuild or replace. But here's what really happened. After 15 minutes and $0 spent, I performed a simple electronic reset. The car drove out of my shop running smoother than the day she bought it. No rebuild, no replacement, just a reset that cleared corrupted data from the transmission control module. This isn't a one-time miracle. This is reality for 97% of modern vehicle issues. I've been turning wrenches for over 2 decades, and I can tell you with absolute certainty that the automotive industry has changed more in the last 10 years than in the previous 50 combined. Your car isn't just a machine anymore. It's a rolling supercomputer with more processing power than the spacecraft that landed on the moon. And just like your laptop or smartphone, sometimes it doesn't need new parts. It just needs to be turned off and back on again. But here's the uncomfortable truth that keeps me up at night. Most repair shops don't want you to know this. I'm not saying every mechanic is dishonest, but the business model is built on parts and labor. A reset takes 5 minutes and generates 0 revenue. A sensor replacement takes an hour and bills for $200. A transmission rebuild takes 3 days and bills for thousands. Which one do you think gets recommended more often? The number 97% isn't random. It comes from my own shop records combined with data from automotive engineers who've analyzed diagnostic reports from millions of vehicles. When you look at check engine lights, transmission issues, rough idle, poor fuel economy, sluggish acceleration, and electrical gremlins, the overwhelming majority trace back to corrupted data in electronic control modules, not mechanical failure. These modules learn and adapt over time, storing information about how you drive, what fuel you use, even the temperature and altitude where you live. When that data gets corrupted, outdated, or conflicts with new inputs, the entire system can malfunction. Think about the last time your computer froze. Did you immediately assume the hard drive was destroyed? Did you call a technician to replace the motherboard? Of course not. You restarted it. The same logic applies to your vehicle, except most drivers have been conditioned to panic at the first sign of trouble and rush to a repair shop where someone in a uniform tells them what's broken. Today, I'm pulling back the curtain. I'm going to teach you 7 professional-grade reset procedures that I use in my own shop every single day. These aren't band-aid fixes or temporary workarounds. These are legitimate diagnostic and repair techniques that can permanently resolve issues mechanics charge hundreds or thousands of dollars to address. By the end of this video, you'll have more knowledge about your vehicle's electronic systems than most people who work in quick lube shops. You'll know when to reset, how to reset, and most importantly, when a reset won't work so you don't waste time on a real mechanical problem. Before we dive in, do me a favor. If you've ever been quoted an outrageous repair price for something that turned out to be simple, hit that like button. And if you want to learn more money-saving automotive secrets that shops don't advertise, subscribe to this channel. I post new content every week designed to put power and knowledge back in your hands where it belongs. Now, let's talk about why modern vehicles are so prone to electronic confusion and what that means for your wallet. The truth about modern cars. 30 years ago, if your car had a problem, it was almost always something physical. A worn belt, a leaking gasket, a clogged filter. Diagnosis was straightforward. You looked, listened, felt, and smelled. Today, that approach is obsolete. A modern vehicle contains between 50 and 150 electronic control units depending on the make and model. These aren't simple chips. They're sophisticated computers running millions of lines of code, communicating with each other through networks that look more like the internet than anything you'd associate with a car. The engine control unit, or ECU, is the brain of the operation. It monitors data from dozens of sensors, oxygen sensors, mass airflow sensors, throttle position sensors, coolant temperature sensors, NOx sensors, camshaft position sensors, and more. Using this information, it calculates the perfect amount of fuel to inject, the precise ignition timing, and how to adjust variable valve timing for optimal performance and efficiency. It makes these calculations hundreds of times per second. The Transmission Control Module, or TCM, does something similar for your gearbox. It monitors speed, throttle input, engine load, and temperature to determine exactly when to shift and how firm those shifts should be. In modern transmissions with 8, 9, or even 10 speeds, the complexity is staggering. A single miscalculation can result in harsh shifts, slipping, or the transmission refusing to leave second gear. Then you have the body control module, the anti-lock brake system module, the airbag module, the climate control module, the infotainment system, and, depending on your vehicle, modules for adaptive cruise control, lane keeping assist, blind spot monitoring, and more. All of these systems are talking to each other constantly, sharing data and making decisions based on what they learn. Here's where problems start. These modules store adaptive memory. They learn your driving style, the quality of fuel you typically use, the conditions you drive in, and they adjust their programming accordingly. This is called a learning curve or adaptive strategy. For example, if you always drive gently, the TCM will program softer shifts. If you drive aggressively, it adapts to firmer, quicker shifts. If you live at high altitude, the ECU adjusts fuel delivery to compensate for thinner air. This adaptation is brilliant when it works, but it has a fatal flaw. If a sensor sends bad data, the module trusts it and adapts accordingly. If the battery voltage drops or spikes, the module can store corrupted information. If you disconnect the battery without following proper procedure, modules lose their reference points and have to start learning from scratch, which often results in poor performance until they relearn. Worse, if a module gets stuck on old data after you've fixed an actual problem, it continues compensating for an issue that no longer exists. Let me give you a real-world example. A customer brought in a Chevy Silverado with terrible fuel economy. It had dropped from 18 miles per gallon to 12 seemingly overnight. He'd already replaced the air filter and spark plugs with no improvement. When I scanned it, I found the mass airflow sensor was reading correctly, but the ECU's fuel trims were way off. It was dumping excess fuel into the engine, because at some point in the past, the sensor had been dirty and sent low readings. The ECU adapted by increasing fuel delivery. Even after the sensor was cleaned, the ECU kept using the old adaptation. A simple reset cleared the adaptive fuel trim, and within 20 miles of driving, the truck was back to 18 miles per gallon. No parts needed. Just clearing bad data. This is the core concept you need to understand. Modern vehicle problems are often software issues masquerading as hardware failures. Shops are trained to test components, and when a test shows a borderline reading, they recommend replacement. But they rarely ask whether the module controlling that component is operating on corrupted data. Resetting costs them money because it prevents a sale, so it's not the first suggestion. Another critical factor is voltage stability. Your car's electrical system is supposed to maintain a steady voltage around 12.6 volts when off and 13.5 to 14.5 volts when running. But batteries degrade, alternators wear out, and connections corrode. When voltage fluctuates, modules can glitch. I've seen cases where a weak battery caused the airbag light to come on, the transmission to shift erratically, and the fuel gauge to read incorrectly, all at the same time. Replace the battery, perform a proper reset, and every single issue vanished. The bottom line is this: your vehicle is extraordinarily complex, but that complexity makes it vulnerable to electronic errors that are simple to fix if you know how. The following 7 reset methods are your toolkit for addressing these issues before you spend a dime on parts or labor. Each method targets different systems and severity levels. Master these, and you'll be ahead of 90% of drivers and, honestly, ahead of a fair number of mechanics too. If you're finding this information valuable, leave a comment with the number 1. I want to know this is helping you, and I've got something even more powerful to share later in this video. Method 1. The emergency battery reset. This is the oldest trick in the book, but most people do it wrong. The concept is simple. Disconnect the battery to cut power to all electronic modules, forcing them to clear adaptive memory and start fresh. It's like performing a hard reset on your phone, but if you just disconnect the battery and reconnect it 30 seconds later, you're only doing half the job. Here's the professional procedure. First, make sure the vehicle is completely off. Turn the ignition off, remove the key or press the stop button if you have push-button start. Next, locate your battery. In most vehicles, it's under the hood on one side, but in some models, it's in the trunk or under a seat. You'll see two terminals, one marked positive with a red cover or red cable, and one marked negative with a black cable. You're going to disconnect the negative terminal only. This is the ground connection, and removing it safely cuts power to the entire vehicle. Use a wrench to loosen the nut holding the cable clamp. You don't need to remove the nut completely, just loosen it enough to wiggle the cable off the terminal post. Be careful not to let the cable touch the positive terminal or any metal part of the car while it's disconnected. Here's the step most people skip. After disconnecting the negative cable, press and hold the brake pedal for a full 30 seconds. This might seem strange, but it serves a critical purpose. Modern vehicles have capacitors in various modules that store residual electrical charge even after the battery is disconnected. By pressing the brake pedal, you're activating circuits that drain these capacitors. This ensures that all modules are completely powered down, not just sleeping. Now wait. This is where patience matters. I recommend waiting at least 15 minutes, but for stubborn issues, waiting 30 minutes or even an hour can be more effective. During this time, all learned data in the adaptive memory is erased. Fuel trims, idle speed adjustments, shift points, throttle response maps, all of it goes back to factory default. After the wait, reconnect the negative terminal. Make sure it's tight. A loose connection can cause all sorts of electrical problems and even prevent the vehicle from starting. Once reconnected, turn the ignition to the on position without starting the engine. You'll see the dashboard light up. This is the modules waking up and running self-tests. Wait about 10 seconds, then start the engine. Don't be alarmed if the engine idles a bit rough for the first minute or two. The ECU is relearning idle speed. Let it warm up. If you have an automatic transmission, the TCM is also relearning shift points, so the first few shifts might feel a bit different. This is normal and will smooth out quickly. Now, here's what this reset fixes. Check engine lights caused by temporary sensor glitches often disappear. Rough idle stabilizes as the ECU relearns proper air-fuel mixture for idle conditions. Transmission shifting improves as the TCM clears old shift logic and adapts to current conditions. Throttle response can become crisper if the throttle position sensor data was corrupted. Let me tell you about a real case. A Ford F-150 owner called me in a panic. His truck suddenly went into limp mode on the highway, limiting speed to 35 miles per hour. The dashboard was lit up like a Christmas tree. Traction control off, check engine light, service transmission warning. He'd had the truck towed to a dealership where they quoted him $2,800 for a new throttle body and throttle position sensor based on the codes they pulled. Before authorizing the repair, he called me for a second opinion. I drove to his house, performed this exact battery reset procedure, and the truck fired right up with no warning lights. We took it for a 20-minute test drive. Smooth acceleration, clean shifts, zero issues. The problem had been a voltage spike from a failing alternator that corrupted data in the ECU and TCM. The battery reset cleared it, and replacing the alternator, which cost $320 installed, solved the root cause. He saved over $2,400 by understanding that modern problems often need modern solutions, not expensive parts. The downside of this method is that you'll lose some convenience settings. Your radio presets will be erased. The clock will reset. If you have power seats with memory, those settings are gone. Some vehicles require you to reinitialize the power windows, which I'll cover later. But compare a few minutes of re-entering your favorite radio stations to hundreds or thousands of dollars in unnecessary repairs. It's a no-brainer. One important note: if your vehicle has an advanced anti-theft system or requires a code to start after battery disconnection, make sure you have that code before you begin. Most modern cars don't require this, but some European and luxury models do. Check your owner's manual or call your dealership to confirm. Method 2. Strategic fuse cycling. If the battery reset is a sledgehammer, fuse cycling is a scalpel. Instead of resetting the entire vehicle, you're targeting a specific module that's misbehaving. This is incredibly useful when you want to reset one system without losing all your personal settings, or when a full battery reset didn't solve the problem. Every vehicle has at least one fuse box, and most have two. One is usually under the dashboard motherboard on the driver's side, and the other is under the hood in the engine bay. Inside these boxes are dozens of small fuses, each protecting a specific circuit. There are fuses for the ECU, TCM, body control module, ABS system, airbag system, radio, power windows, and more. The key to this method is identifying which fuse controls the module you need to reset. You can find this information in your owner's manual, which usually has a fuse diagram in the back or on the inside of the fuse box cover itself. Many vehicles also have this information available online if you search for your year, make, and model plus fuse diagram. Here's the procedure. Make sure the ignition is completely off. Open the fuse box and locate the fuse for the module you want to reset. Fuses are typically labeled with abbreviations: ECU or PCM for the engine control unit, TCM or trans for the transmission control module, BCM for body control module, ABS for anti-lock brakes. Use a fuse puller or needle nose pliers to gently pull the fuse straight out. Don't yank it or force it. If it's stuck, wiggle it gently side to side while pulling. Once removed, set the fuse aside and wait 10 minutes. This gives the module time to fully discharge. Then, insert the fuse back into the same slot, making sure it's seated properly. Turn the ignition on and check if the problem is resolved. Let me give you a perfect example. A customer with a Dodge Charger came in complaining that after getting an oil change at a quick lube place, his transmission started shifting hard, especially from first to second gear. He thought maybe they overfilled the transmission fluid or damaged something. I scanned it and found no codes, but the shift quality was definitely harsh. Here's what happened. When the oil change shop reset his oil life monitor, they likely cycled the ignition multiple times or disconnected the battery briefly. This confused the TCM, which lost some of its adaptive shift data. Instead of doing a full battery reset and losing all his radio presets and settings, I pulled the TCM fuse, waited 10 minutes, and reinstalled it. We took the car for a drive, and within 5 miles, the transmission was shifting smoothly again. The TCM relearned the correct shift points based on current conditions rather than trying to use corrupted data. Total time, 15 minutes. Cost, $0. Fuse cycling is also incredibly effective for infotainment problems. Modern touch screens can freeze, glitch, or become unresponsive. Before you drive to the dealership and sit in a waiting room for 3 hours, try pulling the fuse for the infotainment system. Wait 10 minutes, reinstall it, and see if the problem clears. I'd estimate this works about 80% of the time for screen freezes. Another application is the body control module. If your power locks, interior lights, or dashboard indicators are acting strange, a BCM reset via fuse pull can work wonders. I had a Chevy Malibu where the interior lights would randomly stay on after the doors were closed, draining the battery overnight. Dealership wanted to replace the BCM for $650. I pulled the BCM fuse for 10 minutes, reinstalled it, and the problem never came back. The module just needed to reboot. A word of caution: be very careful about which fuse you pull. If you pull the wrong one, you might temporarily disable an important system like airbags or ABS, which could trigger warning lights. Always double-check the diagram before removing anything. And if you do accidentally pull the wrong fuse, don't panic. Just reinstall it and the system should come back online. Another tip: take a photo of the fuse box layout with your phone before you start. This way, if you forget which fuse goes where, you have a reference. Some fuses look identical, and mixing them up can cause confusion. Strategic fuse cycling gives you surgical precision. It lets you target exactly the module that's causing problems without the nuclear option of a full battery reset. And because it's so quick and easy, it's often my first troubleshooting step when a customer describes an intermittent electrical issue. If this is making sense and you can see how these techniques could save you serious money, go ahead and hit that subscribe button. I've got 5 more methods to cover, and each one gets more advanced. Method 3. Advanced Throttle Relearn Protocol. Modern throttles are electronic, not mechanical. When you press the gas pedal, you're not pulling a cable that opens a butterfly valve. You're sending an electrical signal to the ECU, which then commands a motor to open the throttle body. This system is called drive-by-wire or electronic throttle control. It offers precise control and allows the ECU to optimize throttle response based on driving conditions. But it also means the system relies heavily on learned data. Over time, carbon builds up in the throttle body. The throttle position sensor can drift slightly, or the ECU's learned idle speed can become incorrect. The result is sluggish acceleration, a touchy or unresponsive gas pedal, rough idle, or even stalling. Many drivers assume the throttle body needs to be replaced, which can cost $300 to $600. But often, a throttle relearn procedure solves the problem for free. Here's how to do it properly. Start with the vehicle completely off. Insert the key, or have your key fob nearby if you have push-button start. Turn the ignition to the on position. This means dashboard lights are on, but the engine is not running. You should see the gauge cluster illuminate. Wait 3 full seconds. Then, press the accelerator pedal all the way to the floor and release it quickly. Repeat this 5 times within 5 seconds. It's a quick tap, 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 tap motion. After the 5th press, wait 7 seconds. Then, press the accelerator pedal all the way down and hold it there for 15 seconds. At this point, you might notice the check engine light starts flashing or behaving strangely. Don't worry, this indicates the ECU is entering relearn mode. After 15 seconds, release the pedal and wait another 7 seconds. Now, turn the ignition off completely, then start the engine. Let the engine idle without touching the gas pedal for at least 2 minutes. During this time, the ECU is relearning the proper idle speed and throttle position. The RPMs might fluctuate a bit. That's normal. After 2 minutes, turn the engine off. Wait 10 seconds, then start it again. Take the vehicle for a drive. Accelerate gently and vary your speed. Drive in stop and go traffic if possible. This helps the ECU relearn throttle response across different load conditions. After about 10 miles of mixed driving, the system should be fully adapted. What does this fix? If your gas pedal felt like it had a delay or dead spot where you'd press it and nothing would happen for a split second, this often resolves it. If your idle was hunting, meaning RPMs would go up and down instead of staying steady, this smooths it out. If your vehicle hesitated during acceleration or felt like it was stumbling, this can eliminate that behavior. Real-world example. A Toyota Tacoma owner contacted me because his truck felt gutless. When he pressed the gas, there was a noticeable lag before the engine would respond, almost like there was a delay in the computer processing his input. He'd taken it to 2 shops. One said the throttle body was dirty and wanted to clean it for $150. The other said the throttle position sensor was failing and wanted to replace the entire throttle body assembly for $480. I had him perform this exact throttle relearn procedure over the phone. Took about 5 minutes. Then he drove the truck around the block a few times. He called me back almost laughing. The lag was completely gone. The truck felt responsive and powerful again. What happened? Over time, the ECU had adapted to compensate for minor carbon buildup in the throttle body. When he'd recently used a fuel system cleaner that actually cleared some of that carbon, the ECU was still using the old compensation data, causing the throttle to feel sluggish. The relearn cleared that old data, and the ECU adapted to the now clean throttle body. Problem solved with zero cost. This procedure also works wonders after you've actually cleaned a throttle body. If you've done that job and the engine idles rough or stalls afterward, it's because the ECU is still using old idle speed data that compensated for a dirty throttle. The relearn fixes it immediately. One variation worth knowing. Some vehicles, especially Nissans and Infinitis, have a slightly different procedure. For those, you turn the ignition on, wait 3 seconds, then rapidly press and release the gas pedal 5 times in 5 seconds, then immediately start the engine and let it idle for 20 seconds. Then rev it to 3000 RPM and hold for 20 seconds. Check online for your specific make and model if the standard procedure doesn't work. The throttle relearn is one of those secret weapons that mechanics use all the time but rarely tell customers about. Why? Because if you know how to do it yourself, you won't pay them to clean your throttle body or replace your throttle position sensor unnecessarily. Method 4. The professional scanner method. Everything I've covered so far can be done with zero tools, but if you want to take your diagnostic capability to the next level, investing in an OBD2 scanner is a game changer. OBD2 stands for Onboard Diagnostics version 2, and every vehicle sold in the United States since 1996 has an OBD2 port, usually located under the dashboard on the driver's side. A basic OBD2 scanner costs $20 to $50 and can read and clear check engine light codes. A mid-range scanner costs $100 to $200 and can read codes from multiple modules, view live data, and perform some reset functions. A professional level scanner costs €500 and up and can do everything including module programming, but that's overkill for most DIYers. Here's why this matters. When a check engine light comes on, your vehicle stores a diagnostic trouble code, or DTC. This code points to the system or sensor that's causing the issue. For example, P0420 means catalyst system efficiency below threshold, which usually means a failing catalytic converter or oxygen sensor. P0171 means system too lean on bank 1, indicating a vacuum leak or faulty mass airflow sensor. Without a scanner, you're driving blind. You see a check engine light, and you have no idea if it's something minor like a loose gas cap or something serious like engine misfires. Shops know this, and they use it to their advantage. They scan your car, see a code, and recommend the most expensive fix related to that code. They're not always wrong, but they're definitely not always right either. Let me tell you about a customer in California who was told by a shop that she needed a new catalytic converter because her check engine light was on and the code was P0420. The quote was $1,200 for a new CAT Plus installation. She called me for a second opinion. I told her to buy a $30 scanner from Amazon, plug it into her car, and send me the exact code. She did. It was indeed P0420. But when I asked her how the car was driving, she said perfectly fine. No loss of power, no unusual smells, no rattling noises. I walked her through clearing the code with the scanner and told her to drive for a few days. If the light came back on immediately, the CAT was likely bad. If it took a while or didn't come back at all, it was probably a false code triggered by a temporary issue. She drove for 2 weeks. The light never came back on. What happened? At some point, she'd used cheap gas or driven in stop and go traffic for an extended period, which caused a temporary condition where the oxygen sensors detected lower than ideal efficiency. The ECU stored the code and turned on the light, but the actual catalytic converter was fine. Clearing the code and letting the system reset resolved it. She saved $1,200 with a $30 tool and a phone call. Beyond just reading codes, a good scanner lets you clear codes, which is essentially a reset for the ECU. When you clear a code, you're telling the ECU to forget that fault and start monitoring again from scratch. Many issues don't reoccur after a code clear, especially if they were caused by a temporary condition like low fuel, bad gas, or extreme temperature. Mid-range scanners also let you view live data, which is incredibly powerful for diagnosing real problems versus phantom codes. You can watch oxygen sensor readings, coolant temperature, throttle position, fuel trim, and dozens of other parameters in real time. If a sensor reading looks wrong, you know that's the problem. If all the readings look normal but a code is stored, it's likely a data glitch, not a hardware fault. Some advanced scanners can perform module-specific resets. For example, you can reset the oil life monitor, reset the transmission adaptive memory, or even perform a throttle relearn through the scanner menu. This makes the process even easier than the manual procedures I've described. My advice is to start with a basic $30 scanner if you just want to read and clear codes. If you find yourself using it often and wanting more capability, upgrade to a $100 to $150 model. Brands like FXD, Ansell, Blue Driver, and Autel make reliable options at various price points. Avoid the absolute cheapest no-name brands on Amazon as they can be unreliable. Having a scanner in your glove box is like having a medical degree for your car. You can diagnose problems, clear false alarms, and walk into a repair shop armed with facts instead of fear. And when a shop tries to sell you a $1,000 repair, you'll know if they're being honest or taking advantage. Comment with the number 2 if you've made it this far and you're learning something valuable. I want to see who's actually committed to taking control of their vehicle maintenance instead of blindly trusting shops. Method 5. Complete System Purge. This is the nuclear option. It's not for every situation, but when your vehicle is acting completely insane and nothing else has worked, this procedure can save you from a multi-thousand-dollar repair bill. The Complete System Purge combines elements of the battery reset and fuse cycling, but takes it further by ensuring every single module is fully powered down and forced to rebuild its adaptive memory from absolute zero. Here's when to use this method. Your car is in limp mode and won't come out. Your transmission is shifting erratically despite no mechanical issues. Your check engine light keeps coming back on for the same code even though you've replaced the part. Your idle is all over the place and nothing stabilizes it. Multiple warning lights are on with no clear cause. Basically, when your car feels possessed by a demon and traditional resets haven't helped. The procedure is more involved, so pay attention. Start by turning off the ignition completely. Disconnect the negative battery terminal like we covered in Method 1, but this time you're going to go a step further. After disconnecting the battery, open both fuse boxes and locate the fuses for the PCM or ECU, the TCM, and the BCM. Pull all three fuses and set them aside. Now, press and hold the brake pedal for a full 30 seconds to drain residual power. Here's the key difference. Wait 30 minutes. Not 15, not 20. A full 30 minutes. During this time, every capacitor in every module is completely drained. All learned data is erased. All stored faults are cleared. It's like wiping the hard drive and reinstalling the operating system. After 30 minutes, reinstall the three fuses. Reconnect the negative battery terminal and tighten it securely. Now, before you start the car, turn the ignition to the on position and let it sit for 30 seconds. This gives the modules time to wake up and run their initialization routines. Start the engine and let it idle with all accessories off. No radio, no air conditioning, no lights, just the engine running. Let it idle for 5 minutes. The RPMs might fluctuate. The engine might sound a bit rough. That's normal. After 5 minutes, turn on the air conditioning and let it idle for another 5 minutes. This helps the ECU relearn idle speed under load. After a total of 10 minutes of idling, turn off the engine. Wait 10 seconds, then start it again. Let it idle for 2 more minutes, then shut it off. You're done with the reset portion. Now comes the relearn drive cycle. Take the vehicle on a drive with varied conditions. Start on flat residential streets at 25 to 35 miles per hour. Drive gently with smooth acceleration and braking for about 5 miles. Then get on a main road where you can drive 45 to 55 miles per hour for another 5 miles. Finally, if possible, get on a highway and drive at 60 to 70 miles per hour for 10 miles. The goal is to expose the vehicle to different speeds, loads, and throttle positions so the modules can relearn across a full range of conditions. During this drive, the transmission might shift a bit oddly for the first few miles. Shifts might be delayed or abrupt. Don't panic. The TCM is learning. By mile 20, things should smooth out significantly. The throttle response might also feel a bit strange initially, but will normalize quickly. For the next 50 to 100 miles, drive as you normally would. The vehicle is still learning and adapting. You might notice gradual improvements in shift quality, idle smoothness, and throttle response as the modules collect data and optimize their programming. Real case. A Hyundai Sonata owner was told by a dealership that his transmission needed to be rebuilt for $4,200 because the car was stuck in limp mode and wouldn't shift past third gear. The diagnosis was based on multiple transmission fault codes. Before authorizing the repair, he reached out to me. I asked a few questions. Had he recently had any electrical work done? Yes, a new alternator 2 weeks prior. Had the battery been disconnected during that work? Yes, that was the clue. When the alternator was replaced, the modules lost power and never properly reinitialized. The TCM was operating on incomplete data and defaulted to limp mode for protection. I walked him through the complete system purge over a video call. After the 30-minute wait and the relearn drive cycle, the car was shifting perfectly through all gears with no warning lights. The transmission was never broken. The TCM just needed a complete reset and relearn. He saved over $4,000 with patience and the right procedure. The complete system purge is not something to do casually. It erases everything. Radio presets, clock, seat memory, infotainment data, all gone. You'll also need to reset power windows, which I'll cover next. But when you're facing a multi-thousand-dollar repair quote for something that might just be corrupted module data, spending an hour hour on this procedure is absolutely worth it. One thing to note, some vehicles, especially European makes like BMW, Mercedes, or Volkswagen, might require a professional scan tool to perform certain relearn procedures after a complete system purge. If you try this method, and the car still isn't right after 100 miles of driving, it might need a trip to a shop with the proper equipment to finalize the relearn. But even in those cases, you've still eliminated the possibility of a mechanical failure and narrowed the issue to a software solution, which is usually cheaper. Method 6. Module-specific precision resets. While the nuclear option resets everything, sometimes you need a targeted strike. These module-specific resets address common issues that plague modern vehicles without requiring a full system purge. I'm going to walk you through 8 precision resets that solve 80% of the most annoying problems drivers face. First, the TPMS reset. After inflating your tires to the correct pressure, the tire pressure monitoring system light might still be on. This drives people crazy, and many pay a tire shop $50 to reset it. Here's how to do it yourself. Turn the ignition to the on position without starting the engine. Locate the TPMS reset button. It's usually under the steering wheel, inside the glove box, or sometimes near the driver's side door jamb. Press and hold it until the TPMS light blinks 3 times, then release. Start the engine and drive for 10 minutes at speeds above 30 miles per hour. The system relearns the tire pressures, and the light goes off. If your car doesn't have a TPMS button, check your owner's manual. Some vehicles require you to use the infotainment system menu to initiate the relearn. Second, the HVAC reset. If your climate control is acting strange with air blowing from the wrong vents, temperature fluctuating randomly, or the system not responding to controls, the blend door actuators might be confused. Many vehicles allow you to reset the HVAC system by turning the ignition on, then pressing and holding the recirculation button and the rear defrost button simultaneously for 10 seconds. You'll hear the system cycle through all the blend doors and actuators, recalibrating itself. This works on many GM, Ford, and Chrysler products. Third, the steering angle sensor reset. After a wheel alignment, battery replacement, or steering repair, you might notice the steering wheel isn't perfectly centered or the electronic stability control light is on. The steering angle sensor needs to be recalibrated. Start the engine. Turn the steering wheel fully to the left until it stops, then fully to the right until it stops. Return the wheel to dead center and drive straight for 100 to 200 yards. The sensor recalibrates itself during this process. Most modern vehicles do this automatically, but if the light stays on, this manual procedure usually clears it. Fourth, transmission adaptive memory reset. If your transmission is shifting oddly, but you haven't done a full system purge, you can reset just the TCM's adaptive memory. Turn the ignition on without starting the engine. Press the gas pedal all the way to the floor and hold it for 10 seconds. While holding the pedal down, turn the ignition off, then back on. Continue holding the pedal for another 10 seconds, then release. Wait 2 minutes, then start the engine. The TCM has cleared its learned shift points and will relearn based on your driving style. And this is especially useful after a transmission fluid change. Fifth, infotainment factory reset. Touchscreens freeze, Bluetooth won't pair, navigation acts up. Before you drive to the dealership, try this. Go into the System Settings menu. Look for an option labeled Factory Reset, Master Reset, or Restore Default Settings. Select it and confirm. The infotainment system reboots and clears all stored data. You'll need to repair your phone and re-enter any saved addresses, but 90% of software glitches disappear. Some systems require you to hold down specific buttons like Volume Up, Power, and Seek simultaneously for 10 seconds to force a reset if the screen is completely frozen. Sixth, Auto Window Reset. After a battery disconnect, power windows often lose their one-touch function. The window won't go all the way up or down automatically, or it reverses halfway as if something's blocking it. Here's the fix. Roll the window all the way down and hold the switch for 5 seconds after it reaches the bottom. Then roll it all the way up and hold the switch for 5 seconds after it reaches the top. Repeat this process 2 or 3 times. The window control module relearns the full travel range and restores auto up, auto down functionality. You might need to do this for each window separately. Seventh, body control module reset. Odd electrical gremlins like interior lights staying on, door locks acting working randomly, or dashboard warnings for systems that are working fine often point to a confused BCM. Locate the BCM fuse as covered in Method 2, pull it for 10 minutes, and reinstall it. Many weird behaviors vanish immediately. If the fuse doesn't solve it, some vehicles allow a BCM reset through a specific button sequence. For example, some Fords require you to lock and unlock the doors with the key 3 times, then turn the ignition on and off 3 times. Check online forums for your specific make and model. 8th, cruise control reset. If cruise control suddenly stops working or behaves erratically, it might just need a reset. Start the engine and accelerate to about 40 miles per hour. Activate cruise control, let it hold speed for 30 seconds, then deactivate it. Repeat this process 3 times. The cruise control module often recalibrates during this process. If that doesn't work, the brake light switch might need adjustment, but the reset is worth trying first. These targeted resets solve specific problems without the hassle of a full system purge. I keep a list of these procedures on my phone because I use them constantly. A customer with a Honda CR-V called me panicking because her TPMS light came on after rotating her tires, and the tire shop wanted $75 to reset it. I talked her through the button procedure over the phone in 2 minutes. She was amazed at how simple it was and angry that the shop tried to charge her for something so basic. The key takeaway is that modern vehicles have dozens of modules, and each one can be reset individually if you know the procedure. Before you replace parts or pay a shop, try the appropriate targeted reset. More often than not, it's all you need. Method 7. Preventive maintenance resets. Everything we've covered so far has been reactive. Something goes wrong, and you perform a reset to fix it. But what if I told you that performing strategic resets before problems occur can prevent issues and keep your vehicle running optimally for longer? This is preventive electronic maintenance, and it's something almost no one talks about. Just like you change your oil every 5,000 miles to prevent engine wear, you can reset certain modules periodically to prevent data corruption and maintain peak performance. Think of it as spring cleaning for your car's brain. Here's a preventive reset schedule I recommend. Every 6 months or every 10,000 miles, perform a basic battery disconnect reset. This clears accumulated adaptive data that might be drifting out of spec and lets the ECU and TCM relearn based on current conditions. It's especially valuable if you've changed your driving style, switched fuel brands, or experienced significant seasonal temperature changes. Modern modules adapt slowly over time, and sometimes they over-adapt, compensating for conditions that are no longer relevant. A periodic reset keeps them aligned with reality. Once a year, perform a throttle relearn procedure even if you're not experiencing any symptoms. Over 12 months, a tiny amount of carbon accumulates in the throttle body. It's not enough to cause obvious problems, but it's enough that the ECU starts compensating with altered fuel and timing maps. A relearn prevents this compensation from going too far. You'll often notice the vehicle feels slightly more responsive, and fuel economy improves by a mile per gallon or 2. Every time you change your battery, always perform a complete battery disconnect reset with the extended wait time and proper idle relearn. Never just swap batteries and drive away. New batteries can have slightly different voltage characteristics than old ones, and modules need time to adapt. Skipping this step is one of the most common causes of weird behavior after battery replacement. After any major service like spark plug replacement, air filter replacement, fuel system cleaning, or throttle body cleaning, perform the relevant relearn procedure. When you change components that sensors monitor, the modules need to relearn based on the new baseline. Shops often skip this step, which is why customers sometimes complain that their car runs worse after maintenance. If you live in an area with extreme temperature swings, perform a seasonal reset. When winter turns to spring or summer turns to fall, the density of air changes significantly, affecting engine performance. A reset lets the ECU adapt to the new seasonal conditions rather than trying to use data from 3 months ago when the air was much hotter or colder. Consider this: a vehicle's ECU makes calculations based on learned data about fuel quality, air density, throttle response, and more. Over time, if conditions gradually change, the ECU adapts incrementally. But if those incremental changes stack up over months or years, you can end up with an ECU that's operating on data that's significantly different different from reality. It's like the old game of telephone where a message gets distorted as it passes through many people. Each small change seems fine, but the cumulative effect is off target. A periodic reset wipes that accumulated drift and forces the ECU to start fresh. I've seen vehicles that have been running okay but not great suddenly feel much better after a preventive reset. The owner didn't even realize their car had been underperforming because the degradation was so gradual. I personally reset my own vehicle every 6 months like clockwork. My truck has 180,000 miles on it, and it still runs like it has half that. I'm convinced that regular electronic maintenance is a big part of why. It's not just about fixing problems, it's about preventing them in the first place. Here's a preventive maintenance calendar I recommend you save or write down. Every 6 months, battery disconnect reset. Every 12 months, throttle relearn procedure. Every battery replacement, complete system purge with idle relearn. After any engine or transmission service, relevant module reset. Seasonal changes, spring and fall, basic reset. After any fuel system cleaning or throttle body cleaning, throttle relearn and battery reset. Following this schedule adds maybe 2 hours of work per year, and it can extend the life of your vehicle's electronic systems dramatically. It's also a great way to catch developing problems early. If you perform a reset and the vehicle immediately starts acting up again, that's a sign of a real hardware issue that needs attention. But if the reset makes things run smoothly, you know the systems are fundamentally healthy. This is truly next-level stuff that even most professional mechanics don't think about. They're focused on fixing what's broken, not on maintaining what's working. But you're not most people. You're someone who's taken the time to learn this information, which means you're already ahead of the curve. Diagnostic Decision Tree. At this point, you have 7 powerful methods in your toolkit, but knowing which method to use for which problem can be confusing. Let me give you a simple decision tree to guide your choices. If you have a check engine light, start with method 4. Use an OBD2 scanner to read the code. Clear the code and see if it comes back. If it doesn't, it was a temporary glitch. If it does come back within 50 miles, you likely have a real issue that needs diagnosis, but at least you'll know the code and can research it or get a second opinion from a shop. If your transmission is shifting roughly or erratically, start with method 2, the strategic fuse pull for the TCM. If that doesn't help, move to method 1, the battery disconnect reset. If the problem persists, try method 5, the complete system purge with relearn drive cycle. If it's still acting up after that, you likely have a mechanical transmission issue that needs professional diagnosis. If your idle is rough or your throttle feels unresponsive, start with method 3, the throttle relearn procedure. If that doesn't fix it, move to method 1, the battery disconnect reset. If the issue continues, you might have a dirty throttle body or a failing sensor that needs physical attention. If you have random electrical issues like lights not working right, locks acting strange, or dashboard warnings with no clear pattern, start with method 2, pulling the BCM fuse. If that doesn't solve it, move to method 1, the full battery reset. If problems continue, you might have a wiring issue or a failing body control module that needs professional diagnosis. If your vehicle just feels off, like performance is sluggish, fuel economy is down, or something just doesn't feel right, start with method 1, the battery disconnect reset. This clears accumulated data and often restores normal feel. If that doesn't help, move to method 3, the throttle relearn. These two methods combined solve most vague performance issues. If you're dealing with limp mode, multiple warning lights, or severe symptoms, go straight to method 5, the complete system purge. This is the nuclear option, and it's designed for serious electronic confusion. If the problem persists after this and the relearn drive cycle, you likely have a real mechanical or sensor failure that requires parts replacement. For preventive maintenance or after battery replacement, always use method 7, the preventive reset schedule. Don't wait for problems. Stay ahead of them. The key is to start with the least invasive method and work your way up. Don't jump to the nuclear option unless you've tried simpler resets first. And always give the vehicle time to relearn after a reset. Don't judge results immediately. Drive 20 to 50 miles and let the systems adapt before deciding if the reset worked. Conclusion. Let me bring this all together. The automotive industry has changed more in the last decade than most people realize. Your vehicle is no longer just a machine. It's a sophisticated computer network on wheels, and like any computer, it can develop software problems that masquerade as hardware failures. The 7 methods I've taught you today, the emergency battery reset, strategic fuse cycling, advanced throttle relearn, professional scanner method, complete system purge, module-specific precision resets, and preventive maintenance resets, give you the power to diagnose and solve 97% of the issues that send people to repair shops. I'm not saying mechanics are bad or that you should never visit a shop. Real mechanical problems exist, and they require professional expertise. But the overwhelming majority of issues with modern vehicles are electronic glitches, corrupted data, and modules that just need to be rebooted. Knowing the difference between a software problem and a hardware problem is the key to protecting your wallet. Think about how much money this knowledge can save you. A transmission rebuild costs $3,000 to $6,000. A complete system purge costs nothing and takes an hour. A catalytic converter replacement costs $1,000 to $2,500. Clearing a false code with an OBD2 scanner costs nothing and takes 2 minutes. A throttle body replacement costs $400 to $700. A throttle relearn procedure costs nothing and takes 5 minutes. Over the lifetime of vehicle ownership, mastering these reset techniques can easily save you $5,000 to $10,000 or more. And beyond the money, there's something empowering about understanding how your vehicle works and being able to fix problems yourself. You're no longer at the mercy of a shop telling you what's wrong. You can verify, you can test, you can make informed decisions. If this video has helped you, I need you to do 3 things. First, hit that like button. It tells YouTube that this content is valuable and helps other people find it. Second, subscribe to this channel. I post new videos every week on automotive topics that shops don't want you to know about. And third, leave a comment telling me which method you're going to try first. I read every comment, and I love hearing success stories from people who've saved money using these techniques. Remember, your car doesn't need a mechanic for every problem. Sometimes it just needs a reboot. You now have the knowledge to do that yourself. Use it wisely, save money, and take control of your vehicle maintenance. Thanks for watching, and I'll see you in the next video.